Okay, today we're going to take a look at my very first oscilloscope. This is a Tektronix TDS 420A. Now, I picked this thing up on eBay. Cost me about $50. That was mostly shipping because the screen was dead. Now, it's a CRT, and on the back there's a VGA output, so I figured, oh well, if the CRT is blown up, big deal, I can just use the VGA output. Now I can just use the scope anyway. So I get the thing, and it's pretty obvious the screen works fine. It's just turned down in brightness. So all I did was take the top off, open up around by the CRT, and there's a whole bunch of potentiometers, and I just changed the brightness, and that was it. So I had a fully working scope. The catch is, this thing uses, well, right now it's pulling 2 watts and it's off. But this thing uses like 150 watts. It's a 4-channel, 200 megahertz scope, but it's only 100 meg samples per second. Now, a modern 200 megahertz scope is like 2 gig samples per second, so 20 times that. So, not a very useful scope. This thing aliases like crazy. The UI is super slow. It does not take much to change a setting and have it so that the waveform just draws ridiculously slow, and it's just, you can tell it's just way underpowered. I mean, you know, obviously at the time, I mean, this was a top of the line, super expensive scope. This thing originally cost something like $20,000 with all the options that mine has installed. Today, it's just way too big. I mean, this thing is the length of my desk. It's huge. I mean, I can't even see my Rigel scope behind this thing. It's so big. This is a full depth of like a standard rack. And in fact, when I originally got mine, it had option 1R from Tektronix, which gave it a rack mount. So yeah, this thing is huge. And one of the other things is, if you look on eBay, these things actually show up kind of cheap, like around $100, because most people seem to think that they're broken because they take a really long time to start up. And if my recording software, let me start my recording. If my recording software is working, we can take a look at just how messed up the startup sequence is. Now, from what I can tell, this is perfectly normal, and they all do this. But let's just sit back and watch how this thing starts up, and maybe we'll get an idea of why people think this thing's broken. Okay, nothing yet. It takes a little, the initialization takes a little while. Okay, so yeah, okay, so we got an image. That looks fine. It's telling us to wait, and we wait, and oh, okay, the image kind of, wait, what? Huh? Wait, okay, no, well, wait, and we wait. Yeah, so if you are your average eBay seller who doesn't know anything about this thing, and you turn it on and it starts just making all these garbled screens and stuff, most people aren't going to keep waiting for it to finish all the tests. And they just go, yeah, that's broken, and just sell it as a broken scope. Now, my particular scope, copyright 1991 to 1996, it has quite a few options installed. It has option 05, which allows it to do video triggering. Option 13, which lets it gives it a card that has an RS-232 port and a Tektronix printer port, so you can print and store stuff that's on the screen. Option 1F, which is what gives you the floppy drive and the file system. It allows you to save waveforms and settings to the floppy drive. It has option 1M, which gives it 120,000 points of record memory, which is pretty impressive for the time. I think the standard is only like 1,000. It also has the DSP math option, which is 2F, which allows it to do integrals, differential math, and FFTs. So it does actually have a lot of somewhat modern features. And if I get up and hit my switch on my function gen, there we go. I'm giving it a 25 megahertz square wave, which doesn't look very square, but then again, I'm just running it through a BNC cable, just straight in, and yeah, so there you go. It's a almost square wave, and it does work. Like you know, you can get your signal, and you can see how slowly it actually generates the image once you get to different horizontal positions, and we can actually see just how much it aliases. See, oh, there you go, already aliasing. You know, there's a signal there. It's getting confused because the sample rate's too low. So if we go back down to something more meaningful, you can see it just really slowly draws stuff in, and the whole UI gets really slow too. Like you can adjust the trigger in it. Right now it's not too bad actually, but under certain circumstances it just gets ridiculously slow. So it's kind of hard to use in that sense because it's really frustrating watching it just sit there and wait to catch up on all your actions. It has a built-in help system with a little smiley face at the bottom, and it's just so funny because this is like a professional lab equipment, and they just stuck a little smiley face down there for no reason. But oh, the time's set wrong. Oh no, what if my battery's dead? The scope does actually have like a lot of your modern stuff in it, despite it being you know, 20 years old, 20 plus years old. You can do all your frequency measurements, and there's lots of pages of it in this. Duty cycle, delay, peaks, all that kind of stuff. RMS. Let's add an RMS one. There you go. So you know, it can do up to 4 measurements at once. It's actually pretty decent. Like I said, it's got a lot of good features. It's just old and slow. So you can do where's my control? Oh yeah, you can do dot mode, intensified samples. Now, I think this is actually a proper intensity graded display, but it just, I don't know, there's like a delay on it or something. I don't know if that's part of the processing for it, or if it always just puts it into a delayed mode whenever you're doing these special waveforms. But yeah, again, it's kind of annoying because it's just so slow. So you know, if we switch it over to intensified, you get this delayed run after, I don't know. It's probably something really obvious, but again, I don't use it too much. So unfortunately, this is one of those things that, although is useful, you know, someone could take this and, you know, put it to good use. It's huge. It's heavy. I have no idea how I would get it to the person. I actually, at one point, I did save this giant double-walled cardboard box, and the whole idea was to pack it in, and I would just sell it on eBay for like $100. But even that, it's just not worth it. Like, who wants this thing? You can get a Rigol scope. Yeah, it's not going to be 200 megahertz. Most people don't need 200 megahertz. But even my cheap Rigol scope is 25 megahertz, and it's 400 meg samples per second. It's super small. It uses next to no power. It doesn't have a huge fan in it. So, yeah, I mean, if you really need an older scope with like high bandwidth, yeah, but again, the sample rate's so low that it's not really, it doesn't really match up with the speed of the scope, the front end. Supposedly these things are fairly reliable. The power supplies tend to have just worn out caps in them. That's usually the only real problem with this particular model. And yeah, you know, it's a great scope. It's just old, and it definitely shows its age. And just as a side note, you can replace the floppy drive with a flash reader, of course. The catch is that this is a low profile drive. And I found that if you like I tried to replace this when I first got it, and I found that the only ones that were low profile were either really expensive or they weren't high density floppies. Replacing this with a flash one might end up costing you like another $50. And to be frank, that's what my Rigel scope cost. Before we go deeper into the controls, let's look at the physical controls on the unit. We've got soft buttons on the top and, or sorry, the side and the bottom of the display. And we've got a main control dial, some position dials, you know, your usual scale dials. Now, none of these are clicky like a modern scope, which is a little odd coming from a more modern scope. Auto set, which surprisingly does actually usually work on this scope. Not that I recommend using it, but it does actually work, at least in my experience. We got that help button. We have setup, and we can save. This is for saving the waveform and for saving your actual configuration to either the floppy drive, and I think for some stuff it can save it into internal flash memory. We've got our measurement menu, which brings up the controls for your 4 measurements. You can set up cursors. You can do the display, which is what sets the vector mode intensity, that kind of stuff. Hard copy, I think, just tries to print it or save it to the floppy drive. Yeah, floppy drive, there it goes. Oh, no floppy disk. End of the world. And we got traditional run stop button. And shift lets you get into some other stuff like the acquire menu, which lets you turn on high res mode and that kind of stuff. And this is like a service menu, I think. Oh yeah, oh no, this is the printer menu. This sets up for the hard copy button. So you can set it to either save to the floppy drive or output to the printer. Application seems to be for actual installed secondary programs. I don't know if this is something you can configure yourself, or yeah, you know, it's for like fancy options and custom stuff from Tektronix, where you would get, you know, a specific measurement one, maybe for product testing. You know, you have a pass-fail application that is configured to whatever it is you're testing. You hook up all your probes, you run the button, and it just does all the testing and says good or bad. And although mine doesn't have anything in this menu at all. And there's also the status menu, which brings up some stuff like basically what the configuration is on everything. And you can just go through all of these. Waveforms, I/O, banner. Oh, okay, that just brings up that. The probe connectors have the little tabs at the back for interfacing with more advanced probes. They've got a whole wide range of probes available for these ones. One nice thing is you can actually change all the brightness of the individual aspects of the output for the display. Now this isn't a real like intensity graded display. At least in this, as far as I know, that intensity mode does work like a regular, like modern scope like that. But in this setup, you can actually just make everything brighter. And let's pump that contrast way up. How bad is it when it's, seems to make no difference. It's probably just because I'm recording it digitally or something. I don't know. But yeah, you can set that. And if we go into cursor, we can set up bars, just like a modern scope. There's also the system configuration menu that lets you do a few changes, like set the GP, IB bus address and that kind of stuff. You can set all the calibration. Now this explains that you need this specific device to test each one. So if you try and do certain calibration stuff, it'll say you need a certain, 1 volt peak to peak, blah 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 blah, and then it will let you do it. But I've never run any of them because it clears the internal calibration, as far as I know. Same reason I've never removed any of the batteries or anything like that. This thing actually has 2 lithium batteries. You thought it was bad with like HP multimeters, like the 3478A that has a lithium battery in it, that if it dies, it loses all its calibration. Well, this thing has 2. you know, like, but as far as I know, you can actually self-calibrate this thing, like in the sense that if you have the ability to generate the, 1 volt peak to peak square wave that it wants, you can actually just run it. You don't need like special software. The zoom controls work like a modern scope. You can turn on a preview where it will show what it's going to look like zoomed in. You can adjust any delay offsets and stuff like that. And for some reason, there's a dual zoom mode, which, okay, so if we turn it on, okay, so now it's zoomed in. If we turn on the dual zoom, all it does is create a second one. And I guess it's the offset? Yeah, I don't know what the point of having the exact same measurement, the exact same waveform twice is. Anyone know? It just seems really weird that like you can turn on a second copy of it for some reason. So maybe there's a maybe there's a reason for that. I'm not sure. Now I've been trying to find the controls for the FFT and stuff like that, and I cannot find them. The UI in this thing is pretty hard to use. Oh, histogram.
One eternity later.
Ah, here we go. It's the more button. Okay, so you can do channel 1 plus channel 2, but we want FFT. Oh, okay. Change math waveform definition. Huh. Okay, so you can change the scale. Let's do dB volts RMS. Channel 1 is the source. Okay, create math waveform. Okay, so we should have it now. Okay, so it's kind of half off the screen. Let me see if I can just set the signal gen to do just random noise, see what we get with that. Okay, that looks a little more random. Do pulses. Okay, I guess it's doing it. I don't know why it's like halfway off the screen though. Oh, I can control it. Oh, okay. So the controls now control the FFT. Okay, so there you go. Let's switch this back to a sine wave. Let's give it something fast, 25 megahertz. Okay, well, there you go. It does work. Can I get the scale to like... Channel 1. Okay. All right. Getting closer to looking like a... Okay. What'd I do? It's angry now. Okay, yeah, let me switch back to this. Can I control this thing again? Okay, there we go. All right. There. FFTs. Yay. Can I... Let's see if we can do something with this. Window to Hamming. Okay. Do it. Well, it clearly has decent FFT functions, but yeah, good, nice clean signal at the top there at least. One of the biggest problems with this thing is simply that it's monochrome, and if you're trying to look at two waveforms or even four, which I can imagine is a nightmare on this thing, it must just be such a pain in the ass, because how do you even, you can't distinguish any of them. They're all green. Oddly enough, it outputs the green signal and it's just monochrome. But if you do a save and you save a screenshot, it actually saves the screenshot with different colors for the waveforms. So why didn't they just design the video hardware? You know, if they're not gonna put a color display in it, maybe make the video output capable of doing color. I mean, you know, if you're paying for the option for the video out, because I don't think it actually came with the video out standard, because I have seen some on eBay without it. So, you know, make the video card more expensive and more useful. Like, make it so you can at least output a good signal to a VGA monitor. But who knows? I mean, it's fairly old. I mean, it is VGA, so it's not that old. It's not like they didn't have color displays in the 90s. So, yeah, I'm not really sure why they made it so it just outputs the same useless kind of green waveform. Because, I mean, like, if you've got all these channels on, not only does the system slow to a crawl, look at that, look at the frame rate, how much it's dropped. And the thing is, what is it doing there? Not only has the frame rate dropped, but the UI is now super slow. And yeah, like what signal are you looking at there? Which one's channel 1, which one's channel 2, and which one's the FFT? You know, if you just take a look at the screen while you're working and just go, wait, what am I looking at? Did you enjoy taking a look at the scope? Do you want to do a full teardown of it, Moose? Or do you just not like the camera light? Camera light off. Hey, Moose. So on the back here, we've got standard IUC mains input, an auxiliary trigger / external clock input. There's a serial port connection, the Tektronix printer port with a power supply, GPIB port, and a VGA connector. Now, one thing I learned pretty quickly with this thing is these screws are a very fine pitch and a very long thread. So, yeah. One nice touch is that there is a cable wrap here, so you can wrap up the power cord. And this back piece just kind of pops off. And you can see there's cutouts for additional options, although I'm not really sure what they are. They might be for completely different models. I think there's a model above the 420. And then this whole thing just slides off. So the basic layout of the unit is that there's the CRT controller board. This is actually where the pot is that I adjusted the brightness on. There's a main power supply with a big set of connections going out to a big rack, and the floppy drives here with all the front control stuff. There's also another power supply board down there. I think it's all tied together, and you just have one big 20mm fan, which is not the original. I've replaced it with in this case, just a Cooler Master 120mm. And yeah, it's just all power supply filtering and stuff in here, and we've got all these ribbon cables. This is taking video data over to the video subboard, and there's a couple other connections like over to the power. This is probably the soft start power connection, and this is a card cage with all the various option boards installed, including the main CPU board. And on the bottom, you can see where all the magic is happening. This is all the front end. There's this small interconnect board that just links these two boards together. And these look like they're probably the ADCs or something here. And we'll get into this because I haven't actually looked up a lot of this stuff. I've never taken this board out. Board is simply straight PCB tracks. It does nothing else but just connect the two boards. There's no components on it whatsoever aside from the header pins. This is all the front end stuff sealed up. We've also got what are probably the ADCs, unless these might be drivers of some kind. There's a ribbon cable that runs off to the boards. Now I assume that's probably controlling the attenuation and stuff like that. So this is the card cage. It has these 3 plastic pieces which just support all the cards and keep them from wobbling around, which is a nice touch. They kind of just pop out. So once you get those out, there's this big ribbon cable that connects 2 of the boards to the main board up at the top. And this thing just pops out. Now, this is a serial connection. I saw this in the user manual. This allows you to hook up a little adapter to a regular DB9 serial port, and you can interface with the main CPU board, which is this one. And there is a small ribbon connector here you gotta disconnect. It's just a pin, straight pins just crimped to this piece. And another flat flex tucked away in here, which I'm fairly certain you have to disconnect to get this out. Might need a tool of some type, but let's see if we can just pop it out. Yeah, there we go. Alright, so now 2 of these boards, I believe, have battery backups. Now I can see one here. It's just held in place with a little clip. And this is going to be storing all your configuration data. Now, there are 2 of these. I don't know which one. I think one of them stores waveforms and stuff like that, which, you know, who cares if you lose? It's all just stored stuff like that that no one really cares about. And the other one actually stores all the configuration, which is something you definitely do not want to lose. So these are actually screwed in with Torx bits, and I'm going to have to grab a Torx screwdriver. But these are the things that you want to watch out for. You don't want to pull this card out and disconnect this. So I've taken out all the cards. They're all 16-bit ISA cards, although I don't know if they're electrically 16-bit ISA cards. They just have the same connectors. But there's a whole bunch of power supply filtering on the bottom. It looks like these are a whole bunch of voltage regulators too. So they're probably just doing local regulation for everything on this board. And you can see all the flex cables that I had to disconnect. Here's the floppy drive tucked in the corner here. And yeah, there's not much on that thing other than some resistors and that power supply stuff. First up is arguably the least exciting board, and this is the COM port / printer port controller card. It basically just has a serial port and parallel port controller with some memory and just some support chips. There's also a large set of caps and a power supply. This is like a 3 or 5 amp power supply, and that's running to this DC out jack. Now, I believe this is so you can hook up a printer to it. I think they sell a standalone printer that draws power from the unit itself. And I would not be surprised if you could just disconnect the serial port and unscrew it and just use this on the main CPU board, which needs one of these to interface with. It's probably the same pinout. It's probably just a standard serial pinout. Main communications controller is made by Philips. And you can see the power supply stuff. It's basically just a LT switch mode regulator. This is the video card installed. Now, I'm not sure if you can get this unit without this card installed, because it's possible that this card also drives the internal display, but this is what's providing the VGA connector, so it may be an optional card that just is not included in the regular product when you purchase it. But we've got these main National Semiconductor parts that I can't find any information on. Pretty much all the boards have these National Semi parts that are very difficult to track down. 1 or 2 of them showed up as like memory controllers, but I've not been able to find any solid information on any of these cards. They're probably custom-made parts, or at least rebadged parts for Tektronix. This side has a bunch of 60 nanosecond DRAM. This is probably the main video buffer, whereas up here there's some Cypress SRAM running at 25 nanoseconds, and this is probably just buffering stuff. It's possible it's being used as a FIFO, just bringing in data from the scope and buffering it before the system has time to process it. Very similar to the other boards where it's just a couple main control chips and then just a whole bunch of small surface mount logic chips. This board is actually labeled display and it's 6 layers. This card is known as the math card according to the manual. And this is another one of the cards in addition to the video controller we just looked at that connects with the ribbon cable. And this one basically has this large chip, again made by National Semiconductor. It's got to be some kind of DSP, but I can't find any information on it. And a sea of just random logic. And a little bit of memory, and a little bit more down here. This is one of the 2 cards that has this memory backup area that is completely potted, and I've moved a little bit of the potting compound to get a little better look at the chips. These are just standard 128K SRAM chips, and these are actually low power ones designed to work up to or as low as 2 volts. So that explains how they're powering it with this little 3-volt lithium battery, which is still good according to my voltmeter, and the other one is still good as well. They've done this really interesting job where they've run a little border of what I assume is like a very thick epoxy and or silicone, and then you just run this along, and then they fill the area with the this clear potting compound. It's a really interesting method. I don't know why they're doing it. It must be that this is just susceptible to moisture or something, or they're worried it's going to get a little shock and clear the configuration memory, but I don't know. I've never seen this on any other board before. The only other component in this, other than a couple passives, is this Dallas Semiconductor DS1211, which is actually a non-volatile controller chip designed to handle all the power management for the SRAMs. It does stuff like write protects them when the voltage is wonky. It switches it to battery as needed, and it's really just to keep the memory alive and just switch around as the main power gets cut off. It also tests the battery when it starts up, so it's possible it's reporting it to the system. I don't know if the system's actually smart enough to tell you when the battery's low, but I imagine the power on self-test mentioned something about it. Interestingly, all this memory is also the same type of SRAM. It's funny that they're using the exact same memory throughout the whole thing. Like this is battery backed up and this isn't. It's all just SRAM. This is probably all for just handling the waveforms as they're coming in to do the FFT functions and stuff like that. I was wrong. I thought all the cards were made in the US. This one's actually made in Hong Kong. Next we have the main CPU board. So this thing has the main CPU, which is a Motorola 68020, running at 16 megahertz. And what appears to be a memory controller made by National Semi. And we've got another backup section in here, which we'll get to. A little air code display, bunch of dip switches that are all just set to one setting. There's not even anything like configured on them. Some DRAM and the GPIB controller. So this National Instruments chip is probably handling that, and the Altera. This little Altera FPGA or CPLD is probably interfacing the two. There's a bunch of flash memory here made by Intel. That's going to be storing the main operating system. And there's also a small serial header here, which in the service manual you can wire up a connector or order one, and it will let you configure certain things from a serial terminal. There's also a little dip switch down here, set of 2 dip switches. And here we have the main CPU, which is a Motorola 68020 running at 16 megahertz. It's in this black kind of metal and ceramic. Well, I don't know if that's ceramic or not, but it's kind of just a plain package. I'm a little disappointed it's not in a fancy gold ceramic package, but hey, what are you going to do? CPU is tied right into it. It's probably just not even handling anything other than just the operating system. Down on this end, there's a small device, and I wasn't sure what this was, like maybe it's a temperature sensor or something. It turns out it's just an LED, because they actually have a bunch of them on the front panel board, and it's in a kind of unusual older style package, and it's a through-hole one, which is a little, well, it's in a through board, one, I should say, not a through hole. It's a surface mount device, but it just seems a little weird considering there's, you know, it's a card. It's not it's not shining through to the case or anything. This is another 6-layer board. This is a small 64K intersil EEPROM, or EEPROM, I should say. And yeah, I'm not really sure what it's tied into. It might be tied into this because, you know, I think this is a memory controller, but who knows? It could be some kind of FPGA just that's rebranded, or anything around here. It could be some kind of ROM for this. Is probably another serial controller or something. This is the battery backup area of the main CPU board, and here's a little battery connector. This is a Max 690, which is a CPU monitoring circuit. It's really designed to like restart stuff, switch to the battery backup for when power goes out to save memory, that sort of thing. Right next to it is a Philips real-time clock and the associated crystal, and there's just some, looks like transistors or maybe diodes to help switch the power over, and just little pieces of logic. And again, it's all encased in this clear potting compound. Over here there's a bunch of 0 ohm resistors that are setting something on the board. It's probably just a configuration for what model number it is. It's W500 20501, and it also says Volgeo. I don't know. Here's some more of the mystery parts made by National Semi, this one and this one. This one has a 24 megahertz clock crystal next to it. Looks like this is tied into the diagnostic indicator. And looks like it's also tied into this small bit of SRAM. Moving on, the floppy drive is just a standard low profile one, although it does use a FFC connection instead of the 20-pin standard 0.1 inch header, which makes it a little more difficult to find a replacement for if you're trying to do a flash drive replacement. It might be easier just to buy a USB floppy drive and just use a real floppy disk. There's a plastic strip added on one side, and they do this so that it can just slide in, and you add one screw to mount the whole thing. This is kind of standard on a lot of computer cases where they have little brackets to install, and then this is the back plane for all the cards, and you can see it's just got 5 16-bit ISA slots. We've got an input here from the main power supply, and it's this kind of unwieldy solid cable long header, and this just plugs in here and then routes off to the power supply, which we'll see later. There's also ribbon cables that run off. At this end there's a few voltage regulators. Most of them are negative voltage. This is a negative 5 volt. It's another negative voltage one. And it goes through a bunch of caps, and there's some inductors here, so they're just filtering everything. There's also a header that I think that goes down to, it might actually go down to the main power supply as well. It's hard to keep track. They all use the same kind of connectors. And yeah, there's just a whole bunch of resistor packs on this. That's about it. There's also a big fuse here, or sorry, a big resistor here for some reason. I don't know what that's doing. And yeah, this heat sink arrangement just holds everything down when there's screws in it. But when there's no screws, you can bend all the pins. But yeah, they're just screwing it onto this plate. Getting the front panel off isn't too hard. All you have to do is just unhook kind of the obvious points on it. There's a few little retaining clips, and the whole thing kind of pops apart. And this is the connection for the advanced probes where they have the little pin contacts. It's just kind of a standard flat flex cable with a bit of metal reinforcing it. The years are all over the place on this thing. Some of the chips on the CPU board said 1987. This thing says 1991. And I've seen 94, 96, all over the place. Anyway, this is, again, made in the USA, and it's a 2-layer flat flex. The majority of the controls on the front panel are in this removable module, which is most likely a removable part for a couple reasons. One being that it's more likely to fail. It's just got buttons and stuff. So for servicing, it's nice that the whole thing just pops out. But it's also like this so that they can have different models. For example, some of them don't have the floppy drive, so you'd have a different faceplate, or at least a sticker, different sticker. Now, all the circuitry is on the back with these very unique old school rotary encoders. So with this one, it kind of just pops through. But if you have, let's say, this one filled in, it goes all the way through the second piece. If I can line it up, hang on. There we go. There's also another encoder on the back. Oh no, it looks like this just has the one encoder. Looks like they put those encoders on the front. Oh well, we'll get a better look when we take the whole thing apart. But you can just pop these out pretty easily. And on the back, there's just the main sounder for the various beeps. There's a lot of inductors on this. Now, there's 4 of them, and it looks like there's 4 of these encoders. So maybe they're tied to it in some way. Another possibility is that they are tied to the circuit that produces the calibration signal, because this is also on this board. So let me just separate these 2 halves. Okay, now with that off, we can see that there's actually just a rotary sweeper here for the 2 scale dials. And you've got the standard kind of rubber membrane keypad for all the controls. And these are just, I think these are just kind of boring buttons, but take a look. Yep, just plain plastic buttons. I peeled the stickers off. This is a small bit of programmable logic from Lattice. It looks like it's basically a CPLD, although they don't really mention it specifically as a CPLD in the user manual or the data sheet, but might just be they weren't really calling stuff CPLDs at the time. And this chip is a Motorola 68HC705, which is an 8-bit microcontroller for Motorola. Now this does not have any PWM output, so I'm guessing the micro is not creating the 1 kilohertz calibration signal. So it's probably being derived from something else. It's probably just coming through here from the main board. And as you can see, there are a bunch of those through-hole or through-board LEDs on this, each with its own driver transistor and current limiting resistor. On the other side, you can see a little carbon contacts and that it's made in Hong Kong instead of the US, unlike most of the boards. And there's another 6-layer board. And here's where all the LEDs are shining through. And there's a few more over here. These are the trigger ones, and these are the channel select. This 6-layer board is the attenuator board, and this is obviously the input connections from the channels. And we've got this shield here. You just bend the little tabs here to take this off. And there's some rather nifty ceramic hybrids with a whole bunch of relays on them. I have never seen anyone put relays on the top of like a fancy ceramic hybrid. I'm sure they have their reasons. It's probably just because they want to just keep the whole signal on top of that thing. But I can't say I've ever seen that. There's huge banks of capacitors at the end of this on all of them. And this board is just packed with passives. Look at them all. Look at all those resistors and capacitors. And they're all laid out in a nice grid. And we've got these chips, which I'm going to try and heat up a bit and see if I can get one of the heat sinks off. They are not budging. And just some power supply stuff up here. And this is the interconnect that hooks up to this guy and runs off to the next board we're going to take a look at. Well, that's disappointing. It's just a metal lug for a heatsink. There's no markings whatsoever. It may be on the bottom, but I don't think I want to pull the chip off because I'll have to reattach it. But the heatsink came off no problem with just a little bit of heat. But yeah, that's very disappointing. There's no information on it. I mean, it's probably just the front end, just converting it to a differential signal so that it can pass it through the board to the other end. Don't know what this large ceramic part is on the little hybrid modules. It's made by Maxtech, and I don't know, can't find any information on it. But there's one per channel. And what else we got on here? Just a bunch of passives. Here are the relays. 12-volt relays. Rather tall and narrow. And there's a connection to the board. Now this is kind of an interesting construction. because as far as I can tell, the only way they could put this whole thing together is to first mount all the ceramic hybrids, then take this frame, the shielding, attach all the BNC connectors, solder them and the frame to the board, and then hand solder all of these connectors to the boards. Because I don't know how else they would be able to do it, because this is all rigid. It's not like there's a bit of wire here. This is like a rigid connection. So when they're attaching this whole thing, these have to be connected already. So they must lower this in and then one by one solder these. And it's pretty cramped in there. It's rather difficult bit of soldering. These Micrel chips, just before the unknown mystery chip, is they're actually 8-bit serial latched source drivers. So they're probably driving all the relays. And this large board is, well, it doesn't have a name, but we'll just call this the acquisition board since they forgot to put a name on this one. This one is one of the newer boards. It says 1997, made in the US. And it's a 6-layer board, and it's pretty impressive that they were able to make a 250 or 200 megahertz scope, 4 channels in the 90s with just 6 layers. So, you know, I'm sure they did their best to avoid using any more due to the costs, especially at the time. This board is again filled with these unknown chips. I popped the heat sinks off a few of these just to see if there's any information on it, especially these ones since they were off on their own. This is probably all to do with the trigger circuitry, and these are obviously, this is the path of the 4 channels going into these, which again are national semi parts that I can't identify. So they're running a differential pair over the connector into these, which are probably converting it back into a signal for the ADC, and then it's running into these 2 ASICs, I can only assume. There's also a bunch of memory here, all SRAM, and a whole bunch of power supply stuff in this corner. You can see all the big inductors and stuff. A whole bunch of these smaller packages here. Take a look at it and a bit up close, but again, this is an extremely dense board. I mean, look at all the passives just piled onto this board. Clock crystal there. It's a 100 megahertz crystal. This is one of the 4 ADCs on this thing made by Analog Devices. Their high-speed 8-bit analog to digital converters are 150 meg sample per second. Not anything fancy compared to what we have today, but you know, they get the job done, and they're in fancy ceramic gold packages. These are all on semiconductor 10H124 chips, which are actually TTL to ECL logic converters. So the main difference is ECL uses a lot of electricity, but it switches very quickly. And it also has the advantage of it's constantly drawing power, so it is less likely to encounter power supply problems because although the current is high, it is very steady. So they're obviously using ECL logic for a lot of the high-speed stuff on this thing, but they have to interface it with the standard TTL logic. So there's this whole sea of these things all doing the same thing. These are all slightly different. This is 131, 125, 105, but I'm sure they're all basically the exact same thing. They're just interfacing the 2 logic types. I found a little bodge here, and it's pretty much the only one on any of the boards in this whole system. There are very few, if any, bodges on this whole thing. Here are the 2 mystery chips. If you can find any information on them, that'd be rather helpful. Post it in the comments. But there's the big bank of SRAM around each of these, and this is 512K total. Ooh, 15 nanosecond. It's pretty quick. This obviously gets a direct connection to both the DSP and the CPU board, so that explains the ribbon cable. Especially around the logic converters, this is just a sea of small SMD devices. It's really crazy how dense this stuff is. I mean, sure, you can get denser stuff now like on a cell phone, but I mean, especially for the time, you know, late 90s, it's pretty impressive how much stuff is actually on this board. There's all the power supply stuff up here. A couple voltage regulators. -5 volt. To swap out the cooling fan in this thing with a less noisy one, I simply cut the line and use these rather cool 3M, I think they're called Scotch lock connectors. Now, I might have shown these in a previous video, but they are just so cool. You put in the 2 wires, and then you just squash down this yellow tab, or orangish tab, and it squishes down and pierces the 2 wires. But at the same time, it also squeezes out some silicone, which seals the end for moisture. So you just crimp it on, and it with just a pair of pliers, and it just snaps on, pierces the wire, seals it up watertight. It's really cool, and they're fairly cheap. You can get them on eBay, and I think I got these ones off Amazon. I got a big lot of like 100 of them, and then I just used an old fan connector to just wire it in. Buried deep inside it, the chassis is this video driver board. You can see the big flyback transformer in the corner, and these are all the adjustment pots. And again, as I mentioned, one of those is the brightness, which is what fixed my unit. But yeah, it's a pretty densely packed through-hole board. I think I'm going to leave that because it looks like it's going to be a real pain in the ass. I'm going to have to take out the CRT and everything. I don't want to deal with that. On this end of the power supply is where you have the long pin header to connect to the backplane board. And there's also a little connector here labeled CRT power, and there's 2 flat flexes that run off and connect. This is all part of the main power supply, which is split into 2 boards. This one happens to have the label on it that says it's made by Martech Power, and it's designed in California, yet assembled in Mexico. Sounds familiar. Anyway, there's a large connection here that looks like it's mains power running up to the other board that we're going to take a look at, and there's also a ground connection. This thing outputs 5.1 volts at 21 amps, which is kind of crazy. And there's a whole bunch of other supply rails, which aren't nearly as high power. You can see some of the power devices tucked in way in there. And there's another board that I don't really want to take apart, but there's some filtering in there and another transformer. This last board seems to just be input filtering. There's big, huge capacitor here for the input, bulk capacitance, and there's the diode bridge down here, and just more filtering. And tucked against this plate is there's some power devices, and then this just connects to that last board we looked at. Now the fun task of putting all this crap back together.